Hello and welcome to this new video in What's New in Kafka 2.3. My name is Stefan and I'll be introducing you to all the new features of Kafka 2.3. So just before we get started, I just want to say that if you're here, maybe you're willing to learn Kafka, in which case I think my courses online will really help you. And they're all hosted on kafkatutorials.com. So go check out that link. There's 9 courses. There's Kafka for Beginners, Kafka Connect, Kafka Streams, KSQL is a new course that I just released. So all in all, check it out. There's 9 courses available and they may be really helpful for you before you watch this video. Also, I want to say that if you like all these videos and want to get more updates about the newer versions of Kafka, please subscribe to the YouTube channel. That would be really helpful. And then finally, I just want to have an announcement to make before we go in this video, which is that we launched a new Kafka desktop tool called Conductor, and you can go and get it at conductor with a K in the middle, .io, and download the tool, and you will basically have a desktop client which will allow you to control your cluster, monitor the topics, etc. And we really think that'll be helpful for you. If you like it, just send us some feedback and we'll be happy to improve it. All right, so let's get started about Kafka 2.3. We have lots of new changes ahead of us. In summary, the upgrade process is the same as usual, but we have some interesting changes for the Kafka Brokers internals today. We will discuss the new static membership consumer group mode. There was some really good improvements for Kafka Streams in terms of the API, and we have an amazing amount of changes on the Kafka Connect side that I'm really excited about, including some rebalancing improvements. Finally, there's one Kafka security change you should know about if you're using the admin client. So let's get started. First, Kafka internals. So this update is really important. This is KIP 461 and it helps you improve the replica fetcher stability when it handles partition failure. So let's go and have a look at this one. By default, the replica fetcher thread will handle multiple partitions. And if one of these partitions fails for whatever reason, the entire thread will fail and all the healthy partitions will go out of the ISR. Out of Kafka 2.2. But 2.3 will fix that behavior and keeps on replicating the healthy partitions while introducing a new metric called failed partitions count that you should track in your monitoring solution that allow you to see how many of these partitions have failed in terms of replication. Hopefully 0, right? So let's have a look at this replica fetcher thread in 2.2. It has 3 partitions, and let's say that partition 1 fails for whatever reason. Now the whole thread will fail, and all these partitions P0 and P2 will fail as well, and they will be down, and that was really bad. So in 2.3, what happens is that if partition 1 fails, then the replica fetcher thread knows how to handle these things, and partition 0 and partition 2 will still be replicating normally, and then obviously the new metric failed partitions count will increase by 1. Okay, pretty easy, right? But a good change if you have a big Kafka cluster and you have experienced that issue before. Now, KIP 247 is AtMinisr topic partition category and TopicCommand option. So when you have a topic today, it could be fully in sync. That means that all the ISR are all the replicas. It could be under replicated. It's called URP. That means that some partitions are down. And it could be under main ISR. That means that ax equals all, the setting for the producer side, will not work. So number 3 is really what's a bit of a problem. And then finally, offline is when all partitions are down. So under replicated may be fine because you may want to take down a broker for maintenance, but your topics will still work because it's still above the min ISR. So 2.3 will add an AtMinisr. That means that there are some under replicated partitions, but a producer which reproduces using ax equals all can still work. And how do we know this? Well, we can use the Kafka topics --describe command, and there's a new option called --@min_ISR partitions. And that's really helpful to monitor this because that means that if one more partition fails, then your topic will not work anymore. So this is just a new option that's been added and quite a nice one from an operations perspective. Okay, now this is one that's huge if you are a European and you have GDPR and you need to have compaction guarantees in Kafka. Now this will do it. So KIP 354 adds a maximum log compaction lag. So some records must be deleted in a timely manner, for example, for GDPR, or if you have a requirement to store PI data only for 7 days. So there's 2 new settings for controlling compaction, and it's called max.compaction.lag millisecond at the topic level and log cleaner max compaction millisecond at the broker level. Or I can't remember which one, but one or the other, right? And it controls a maximum amount of lag that is allowed before a record must be picked up for compaction. So we used to have the min, now we have the max. And by default, it's max long. That means that it's for backward compatibility. There will be no max imposed, but if you do need a max, please set it here. And that basically completes a bit the compaction feature and gives you more control about how often it should happen in your cluster. Okay, this one is if you are a truly fanatic of automation and like to have secrets maybe in Vault or in other providers, maybe AWS SSM, and you don't want to pull these secrets in Kafka in terms of a flat file, maybe you want to resolve them dynamically. So this is KIP 421, which is automatically resolve external configurations. So in KIP 297, Kafka Connect was able to resolve external variables within configurations. For example, if you were configuring a Kafka Connect JDBC connector, you could retrieve the URL, the password, and the username dynamically using this functioning external variables. But now this mechanism that was introduced in Kafka Connect can be extended to everything, including brokers, connect, producer, consumer, and then client streams. They will all leverage the same semantic and the same mechanism. So how does that work? Well, you have this way of writing things, which is $, you open a bracket, provider name, path, key. And when you use this, you're able to resolve an external configuration. So provider name can be the name of a config provider. It could be whatever you want. It could be AWS, it could be Vault, it could be, I don't know, a file on the system. Path is an optional string that you can pass as a parameter to the provider, and key is a required string to provide the information around the key you're trying to get. So as I said, config provider can be whatever you want. You can even implement your own if you have your own secrets manager within your company. But I think there's examples on the Kafka repository for Vault, if I'm not mistaken. So how does it look like? Well, here's my broker. If I wanted to configure my broker and have SSL key store location, password, and type resolved externally, I could say, okay, they come from Vault, and here's the path to the variables, and here is the name of the property you need to get. And so that's really helpful because now my broker configuration flat file, it doesn't have any secrets in it. It just has a means of discovering these secrets and resolving them, and that makes it way safer and a bit more secure. On top of it, if you wanted to change this key store, etc., the password, the location, you could do so dynamically because you wouldn't have to update this flat file, just the value of them in Vault, for example. So you can do any configs, not just the brokers, but any other configs. And this is an example for a config file that doesn't mean anything. Okay, other Kafka internal KIPs. The first one is that there's a new metric indicating the start time of your broker, and that'll be exposed in brokers, clients, streams, and connect. So everywhere using JMX, you can monitor that. There is this very unknown, I didn't even know it myself, JMX tool as part of Kafka, and you can basically pull JMX metrics using it. Now it's able to connect to a secure JMX port, and for this, you must use SSL and authentication, so now it's an option that's available. And to run this tool, you need to use the Kafka run class command, which is quite a dark command as well. Finally, there is a bit of performance and stability improvements. KIP 402 is improved fairness in the socket service processor. That means that before, new connections were queued and they were not resolved in time, but now new connections are queued and they're resolved in time. It will improve stability and prevent an edge case of out-of-memory error. On top of it, you're able to set the maximum number of connection on top of the config maximum number of connection per IP per broker, and that will be helpful if you want to prevent an attack in terms of too high number of connections connecting to the Kafka cluster at once. So that's it for the internals, lots of changes as you can see, but let's get started with the client. I'm really excited to introduce to you the static membership consumer group option. This one is a new protocol and is a contrast to how today consumer groups work, which is using dynamic membership. So static membership is a membership protocol that's a little bit different, where the consumer group does not trigger a rebalance under certain conditions. So it will still trigger a rebalance if a new member joins the group, if a leader rejoins the group, maybe because there's a topic assignment change, if an existing member offline time is over session timeout millisecond. So that means that if your consumer is down for over 10 seconds by default, it will be still out of the consumer group and it will rebalance. Or if the broker receives a leave group request that contains internally this new setting called group instance ID. But by default, the contrast is that if a static consumer leaves a group, there won't be any rebalance because from a static membership protocol perspective, it is expected to come back. So what would you use this? You would use this when you have a, for example, very stateful application and you can't allow state to be moving over all your instances and you expect them to come back after a short while. So what is this new setting? This new setting is called group instance ID. And it's something that you program in your consumer group. So it's a new consumer property. And by default, if it's null, then that means that you're using the normal behavior that we all know, which is the dynamic membership. But if it's non-null, then it's going to be treated as a static member. And this must be a unique identifier to distinguish each of your client instance. And this is for you to define. So it could be the host name, the IP, maybe if you're using Kubernetes, it could be the pod ID. And the idea is that now all these things will have a static membership. And when it happens that they leave, they're expected to come back and there is no rebalance happening. So that decreases a little bit of the rebalance time or just removes it completely, which can be truly helpful if you have a big consumer group or a big stateful application in Kafka. Overall, if you want to use that feature, you must upgrade your broker protocol to 2.3, and then you will upgrade your consumer to use that feature and you'll be good to go. Okay, other KIPs for clients. 361 is add consumer configuration to disable auto topic creation. So even though there is the broker topic configuration for auto create, if you disable it now on the consumer, it's called allow auto create topics. By default, it's true, but you can set it to false. Then it won't create a topic when the consumer group connects to a non-existent topic. And so there won't be any effect, obviously, with the setting unless the broker does have enabled the auto create topics equals true. There's also a new Log4j Kafka dependent properties for producing to secure brokers. So if you're using a Log4j producer, then there's SASL mechanism in client.js.conf. And finally, for the Serde, deserializer, and serializer, there is a default implementation for close and configure. That's due to the default keyword from JDK 8, because now the minimum JDK for Kafka is 8. So we start benefiting from a few languages improvements from JDK 8 itself. So now let's get into the administration at CLI, a few changes here as well. KIP 351 adds the under main ISR option to describe topic commands. So we've already seen this one, and it was started in 2.2 and finished in 2.3. And so it uses describe option in Kafka topics, and it adds this new option for us. The reason is we want to quickly identify all the topics that will cause a problem if producer uses ax equals all to produce. So all in all, now this producer using ax equals all do have many new options at main ISR and under main ISR to understand if it's ready to crash or already crashing. Now we have a new incremental author config API, so I'm really excited about from the admin perspective. So before, if you wanted to set config using the author configs API, you must know all the configs in advance to override all the old ones with the new ones. Now you just need to say, okay, I want to set one config at a time, and it won't override all the other ones that you haven't set. And so that's a much better and much more stable API for many reasons, for security and for stability, et cetera, et cetera. And so what that means is that the old API alter configs is deprecated, and this new incremental alter configs is the one API to use in your admin client as of 2.3. Okay, so now let's get into Kafka Streams. A few minor changes, no big changes, but a few you should be aware of if you're a power user of Kafka Streams. The first one is that this KStream.flat transform and flat transform values, it's finished in 2.3, so it wasn't exactly finished in 2.2. What's new for Kafka 2.2, my previous video, I did provide an explanation for it, so check it out if you want to learn about it. KIP 428 adds an in-memory window store, and KIP 455 adds an in-memory session store. So if you need performance improvement for whatever reason for your window or your session store, here you go. KIP 258 allows to store record timestamps in RocksDB, and we have two new APIs. We have the timestamped key value store API and the timestamp window store API, which will be really helpful if you use heavily timestamp for whatever reason. In terms of stability, there is KIP 442, and this max poll interval in streams used to be infinite as of 2.2, and the reason is because before 1.0 there was going to be some timeouts, and they set it this way, but now it doesn't make sense to keep it as infinite. So because since 1.0 poll is called very often during the restore, so the old value doesn't make sense. So now we're back at the default value for a consumer, which is max poll interval milliseconds equals 5 minutes. That shouldn't impact you at all with Kafka Streams, but it's still good to know for you. Other KIPs is that now KIP 462 is that local thread ID is used for KStreams. That means that the thread ID are more deterministically generated. And why do we do this? Well, because of the static membership KIP that I just mentioned you about, it will help with minimizing your rebalancing and so on. And will help you set a stable group instance ID. KIP 453 adds a close method to RocksDB config setter, which helps you close this object and fix a potential memory leak that some users were experiencing. Okay, we're almost getting there. But now this is, I think, one of the most important change, which is with Kafka Connect. And I'll try to spend some time with it. This KIP is so interesting. It's KIP 415, and it's been one of the main pain points of Kafka Connect since the beginning, and the users were complaining about it, and I'm so happy that it's finally addressed as of Kafka 2.3. It's called Incremental Cooperative Rebalancing in Kafka Connect. So why do we need this? Well, when you have a big Connect cluster, every connector that you'll submit, maybe a new or an updated configuration, will interrupt the execution of all your existing connectors. So imagine you have 100 connectors running, and you update one of them or you create a new one, then all of them will stop working, even though they're unrelated to the new connector. And why do we have this? Well, that's a big problem because this is just the way it was programmed. So when do we experience this though, is that if, for example, a worker dies in Kubernetes, we will see that stop the world event in Kafka Connect. If you do a rolling bounce, you'll see the same thing. If you scale up and down, and so on. So now the rebalancing process is much later and doesn't have a stop the world event. Instead, when you just update one connector, the other ones still keep on working and are not interrupted. So there's a new setting called scheduled rebalance max delay millisecond, which is a time a worker is allowed to leave before being declared dead. So if you're doing a rolling bounce of a worker and it comes back before that delay, there will not be a rebalance as well, which makes Kafka Connect much more stable and much more usable at scale. For this, you need to upgrade this setting called connect.protocol. It's a new setting and it's backwards compatible. If you're interested into using this, look at the KIP details for the upgrade process. Another tremendously helpful change in Kafka Connect is KIP 449, which adds connector context to the Connect worker logs. So if you have a lot of connectors, again, you would not be able to differentiate the logs of one versus the other. But now there's a new line to be edited in your log4j properties for Kafka Connect, which has this %x connector context %m, and that means nothing to you right now. But if you look at the log file, then you see that everything that I've surrounded in orange, those are some information around the name of the connector and the task name. And so that helps you understand which log line corresponds to which connector, which could be really helpful if you're trying to debug one connector and you have 100 connectors running on that Kafka Connect instance. So a very welcome change as well for Kafka Connect. Other Connect KIPs, you have a connector client config override policy, that's KIP 458, and it gives you worker level or consumer level overrides that's available for you. And you're able to specify now which connectors are allowed to override which setting using that policy. So if you have a managed Kafka cluster, I think that's a really helpful change. By default, none. That means that no configuration can be overridden, and it's up to you to use one of the available implementation or implement your own. Also, the Kafka Connect worker now have distinct client IDs, and so it's called connector consumer connector ID task ID or producer connector ID task ID. So that allows you to differentiate between all the clients spun up by your Kafka Connect worker. And it will help you greatly with monitoring because now they don't have the same name. So you can really understand what goes on for each of your producer and consumer related to your connector in terms of performance and monitoring. Finally, there is a bit of an improvement with the REST API. If you're using the REST API, now if you query the /connectors, it will return you more information. It will return you all the tasks, connector, configs, and status as part of one API call, so you don't have to iterate over those while talking to Connect. I think it's a really welcome and helpful change. Finally, what everyone loves, it's security. So I'll be short on it, but there's one cool new KIP. It's KIP 430, which is to return authorized operations in describe response. What does that mean? That means that now, if your client is authorized to do a describe XXX or describe XXX option, you're able to understand and get back all the included authorized operations of the ACL that your user can do. And why it's cool? Well, it's really cool because now we are able to know in advance what API calls we can or cannot make, whereas before we had to try the API call, maybe get denied, and then try again for another API call. So now in advance, we're able to know if we have the describe ACL, we're able to know all the API calls we can make, which is not too bad from a security perspective and really gives us better user feedback, maybe if you have a admin API for your users. So that's it for Kafka 2.3. As you can see, there's lots of new changes and I went quite quickly over them, but hopefully that gives you a good overview of what may be useful for you, for your cluster to improve its stability, your efficiency on your DevOps, and so on, maybe your consumer groups. And so I hope you liked this video. If you liked it, thumbs up, comment, share, all these things I really like. And if you like the way I explain things, please check out my courses. I really think they can be beneficial to you. Again, it's kafkatutorials.com. All right, that's it. My name is Stéphane Marek, and I hope to see you in the next video.